Welcome back to VTU e-Shikshana program on computer-aided engineering drawing. We are in module 3 dealing with the development of surfaces. We have learned basic things like prisms, pyramids and also funnels. Now I am going to take trays, simple trays and also little bit complicated trays which are having inclination with respect to the reference lines. Now I will take up three basic trays, simple trays. One is this is very simple tray, and also this is the side wings are inclined and this is vertical again, and the base of the tray itself is inclined. I will show you the simple tray which are used in series industries and also serving trays, for example, and also in industries also to carry the articles, components, small components they use it. This is the tray and the corresponding smaller one is this. So you can prepare these trays very easily. I will show you how to do it. And next comes this. The trays are simple now. The side surfaces are inclined little bit. It again depends on the size of the tray. For example, base is around 12 by 24, and then top face edges measures around 20 by 30 or so, or even less. So again this is the tray, and then the inclined tray, the base itself is trapezium type. Here it is rectangle and it is trapezium type. Okay, so again here we have the height remains same, both sides are different. Here also we can have different heights. For example, this one is the rectangle, but this height is smaller, this is bigger, and the top view looks like rectangle only again. So here let us do one by one, and let me take up the first one. So before that, let me show you how the development looks like. For the first one, it looks like this development. I will show you how to do it. Again, second one, this is the development. This is the base of the tray and these are the side surfaces. Next comes the inclined surface, which is having the trapezium shape in for the base of the tray, and these are the side surfaces. Again, we can do it for the same height and different height. Here I have taken the same height both sides. So all the three models. Now let me prepare this. Very simple way of preparing this. Say, assume that I have a sheet of paper or sheet metal, for example, and we have 32 measurement. Here it is 20. Okay. Now I want base to be 24 by 12. 24 by 12, and keep the border say 4 centimeter each. That's all you have to do. Then draw the border, and you can see these lines which you have crossed. Then you try to remove these portions. So now I will do it. Remove this portion. You can readily get the tray now. See, what I am doing is I am removing this corner portion which are crossed by these lines. Okay, because the side surfaces are vertical. Okay, that's what I am doing. Now see, all four sides corner surfaces are removed which are having the border of 4 centimeter each. Now you fold it properly to the base surface level, and then go for soldering or whatever. If this is paper type, you can do this way. I have the sheets retained here, and let me use the stapler and do it. See what I have done. I have removed only one side, this portion to be removed. Okay, I don't want to remove, I will retain, and then I will try to keep this. If it is sheet metal type or paper type, the thickness is more for the paper, I can do this job. Now I have prepared the tray. This is a very simple tray which can be used in the serving and also other things. The tray is ready. So this is how you can prepare the trays. But how exactly you do it as per the projection concept. Projection concept is also easier in this case. Now, we have to remember one thing. Whenever you have the tray and then cut open at these vertical edges like this, then you see that the path traced by the corners, top corners, if I rotate like this, it is always perpendicular to the base edges. It is very important. The path traced by the corners, if I move like this, see for example this is the one, and if I want to show the development, I have to rotate by 90 degree in this case. Rotate by 90 degree or rotate till you reach the surface. Till that process, in that process, the corners, the path of the corners traced by these corners for example, and there that particular path is perpendicular to the base edges. That is very important. Now let me identify these here in this particular case. Now A, B, C, D are top face edges. See, this is A, B, C, D top face edges. 1, 2, 3, 4 are base corners. A, B, C, D are top face corners. 1, 2, 3, 4 are base corners. Now, I would like to draw the development of this as per the projection concept. Now, what I do is, I draw locus of B and locus of A perpendicular to the base edges. Because they are horizontal and vertical, I am keeping vertical and horizontal. For example, locus of B with respect to 1, 2 edge is perpendicular to 1, 2 passing through this corner. Similarly for C, this is for C. Now, what exactly these lines refers to? The locus of corners. Locus of, you can say, corner B. Similarly, it is locus of corner A. This is locus of corner D. This is locus of corner. Why 2 lines? Because if you cut open this, you will get 2 sides. Okay, one is, this point is 1, this is A, this is A. If you close it, if you prepare the model, you will get A. So, this is 1, this is A, this is A. You will get 2 corners there. Now, that is going to be placed on these lines only. Now, how to identify the height? It is very easy here because the line 2B or 1A, 3C, all are vertical. If you look at this, you will get true length only. So you can take directly true length from 2A center, draw arcs. That's all. All are equal. Say 4 centimeter. You take 4 centimeter, do it. Or as per the lines concept, you rotate this, make it parallel and project. You will get same points here. That also you can do. Now, as per the projection and lines concept, what you do is, I am concentrating on 2B now. 2B is vertical, you make it parallel and project. So, what I want is, true length of 2B is this only. Same thing, because it is vertical. If it is inclined, then future problems are that type. I have to find the true length. Here directly you get the true length. Same thing you rotate and do it. Since it is now projection, you will get same thing. Now true length of 2B is this. That is what exactly you have here, same thing. Now you take compass, 2A center, this as radius, draw arc. Again 3A center, draw arc. If for a particular, you can rotate this also and project. Otherwise, you can take compass and then mark here. All these points are easily available now. Now the final projection is this. B, this is C, capital C, this is capital B, this is capital A, again this is capital D, this is capital A. Again, why capital? This is actual points, corners on the flat surface. This is C, okay, this is B. Now join. Here nothing was there beyond this green color boundary. Now I am keeping again this. So now join these points. because this is very clear cut reference. This is vertical. Now if you close it, you will get the all lateral surfaces are vertical only. Okay, unlike other inclined tray. See this. This is the tray I have, all are vertical. So if I cut open and keep it, it will be like this. Okay, same thing I have now. See, very simple. All these sides are equal. And suppose that you want different height, then problem starts. Suppose that I want this different height. For example, this is 5, I will make it 10, then do this job. Yes. Now, the front view of the tray will be this. Still, you have the same procedure. You don't have to wait for this. Simply keep this out. Here it retains. Then draw or same distance. Here you can take directly or as per the procedure, do it. See, this is how you can do it. Same locus you retain. Same locus you retain. Then mark these points. This is C, this is B. Okay. Next comes this. Here you take the same distance. Same distance here. So this is nothing but the projection of the tray development. So here this distance must be equal to this. Once you fold it, you will get different height. Okay, so this will be 20, this is, this is 10, this is 5 or 8, 4, whatever the dimension you get. So this is the tray 1 complete development. Now let me come to this point. So this is the tray, which is actually the very interesting to have the lateral surfaces inclined. Okay, so in question paper or the exercise, what you get is this. Now maybe this is 80 and this may be 120. So here it is 60 and this is 100. So any suitable dimension you may give, and height may be around 20. Okay, so this is how you get the things. Now what you have to do is, since it is symmetrical about both the axis vertical as well as the horizontal, now we can prepare plus mark. Okay, and then do this job 40 both sides and then 30 and prepare this rectangle. Top view is ready now. 1 2 3 4 is the base. 1 2 3 4 is the base, and then A B C D are the top corners, 4 corners. Okay, and we have maintained same height. Okay, now what exactly the development? This is top view. Unlike this only rectangle coinciding top face edges and base edges same, just a rectangle. Here is not a rectangle. We have two rectangles. 1 2 3 4 is the base, and we have, because we have 120 by 100 as the top edges and 60 by 80 as the base edges. So how to do it? Same concept, no difference. Only thing is from where you draw the path. Here, see here, if I cut open this is the tray I have. If I cut open all corners and keep it on the flat surface, assume that I am doing this job now, flat surface, the path traced by these corners, for example, this is 1A, 2B, 1A, 2B, path traced by A in this with respect to this lateral face is perpendicular to the base edge. Since it is horizontal, you have to draw vertical. What about this? Since it is vertical, you have to draw horizontal on the top view. Okay, so it must be perpendicular to the base edge, just passing through the outer corners. So from there, that is the moving end. For example, if you take a straight line, this is moving end, this is fixed end. So moving end locus is this, starting from moving end. Now I can say this particular line in this direction is locus of B. Again, this is locus of B. In two different directions. And similarly, we have this is the locus of A in this direction with respect to 1, 4, and with respect to 1, 2, this is the direction. Because 2 points will come. If you cut open, this is A, this is 1. If you cut open, then you will get 2 points, A and A. Like that, B, B, C, C, and D, D. Now, I can just say this is locus of D, and this is also locus of D. Similarly, this one. Again, here, this is these two are locus of C. Now, what you do is rotate this. Unlike this problem is true length. Here I don't have true length, neither in the front view nor in the top view. Both are inclined. So, you have to make it parallel. This is the concept of straight lines. You make it parallel and project on the moving locus. See, this one is point of reference. Now, what I do is I will keep this point projected onto the locus. See, this is locus of C, and here I can write C, capital C. Yeah, and here also capital B. Now, before going to the different corners, I will try to explain clearly. Let me join 2B. This particular 2B line refers to true length of slant edges, because all slant edges are equal in this particular case. But if you come to this point, it is different. I will tell you what. Okay. So, here is this particular length refers to true length of all slant edges, 1A, 2B, 3C, and 4D. Okay. Even otherwise, you are going to find individually by rotating that if you are interested. Otherwise, you can take this distance and 2S center draw on the loci. Again, same distance you take 1S center, 2B equal to radius draw arcs on the loci. Okay. This is locus and this is also locus. Again, here 4S center draw on the locus. Here also 3S center draw on the locus. Otherwise, you can do here also. See, rotate. Then project. This helps you in solving the problems which are having different heights, as I did here. Okay. Now, I can just say this is A, capital A. This is again A. That is with respect to 1, 4. So, I have identified A and D. And also I identified B and C. Now, how to identify these two? Again, we have the same locus. See, through A, you have drawn already locus. Take this as distance reference, take this equal to radius, draw an arc on this. So, you will get, see, I will show the arc reference. Same, all throughout, all draw arcs on the respective locus. Then, can mark this as A, capital A. Again, this is capital B. This is already C is identified on the perpendicular locus. This is C. Again, this is on the perpendicular. This is A. See that this gap is more, so that the lateral surfaces development will occupy. Otherwise, you have to face overlapping problem. Now, start working for the completion of this. Now, I join AB and join 1 with A, 2 with B. Yes. This one particular portion is over. Similarly, you can take up this, the just opposite to that. 3C, sorry, this is not A, this is D. This is D, because this point is D. Now, join this. Yes, I got 2 segments. 2 more segments I have to get. How to get? Already A and B are identified. C is there. Here D is available. Join them. That's all. See that all these lines are dark. Whatever we are completing, all are dark. Again, this one is dark. Yes. So this is the development pattern, and this is the tray. So the first you have to have tray and then corresponding development. So I have all points A, B and B, C, C, D, D, A, A. This is the base of the tray and these are the lateral surfaces. That's what I have. In red color I have made it dark. The gap between the front view and top view maintain sufficient so that you can accommodate this. So this is about the tray which is having same distance. For example, if you have different distances, for example, this is 5, this is 10, or this is 15, this is 30. What exactly? Whatever we have done here, same thing you have to do. So only thing is the change is from the side you are interested in height, given height. Say for example, I will increase this height. That's all. I will increase this height. I will change little bit. Okay, this becomes B dash C dash. Okay, now corresponding, so also will change. Okay, the top view remains same, no problem. Only thing is you are supposed to get same for the same top view. I have maintained same distance, and this is the locus. These are the locus. Okay, these are the locus. Only this here will get change. Okay, now what you do is take this radius, rotate, make it parallel. This is a line reference. Then you get this point. This is reference B. This is B. Again, this one is C. Yeah, and take same distance here. This is C, and here same distance here. This is B. Okay, that's all. Already we have D and A fixed. No change here. Now join them. Now I have D to C, 3 to C, 3 to B, 3 to B, then 2 to B. Sorry, not to 3 to B, 3 to C, 2 to B. Yes. You can observe here, this is larger, this is smaller. All depends on this. Only thing is maintain sufficient gap between top and front so that you can accommodate. So green color refers to the new reference, modified front view. Top view remains same. You have to consider the concept, the corners of the top edges, then draw perpendicular lines. Perpendicular means perpendicular to the base edges. Since it is horizontal and vertical in this case, I am telling you horizontal and vertical. So, two perpendicular lines. So, this is how you can complete the same height or different height. Okay. So, tray 1, tray 2. So, here different height I have this one. See, same rectangle is there, and here is the height is 20, this is 10. Okay, so you have slope. So if you cut open, then you will get this. See, this is smaller and this is bigger. So this here the inclination will be there. But unlike this one, previous one, we have horizontal and vertical in the top edges also. Here we have inclination because of the slope. So here is the model of inclined tray and the corresponding development. Okay. Now let me take up the last one, which is having the trapezium as the base instead of rectangle. How exactly you complete? Same procedure, no change, but you must be very careful in this particular problem because no horizontal and vertical line works for you except these vertical edges corresponding loci are horizontal, but inclined edges are there. You must be very careful in this. So let me draw first locus of, once you cut open, and the path of ABCD with respect to 1, 4 and 2, 3 are very clear horizontal. This is horizontal, no doubt, horizontal, and this is horizontal because they are vertical. What about 1, 2 and 3, 4? 1, 2 and 3, 4 are not horizontal, neither horizontal nor vertical. It is somewhat inclined. So what you have to do is you have to have the set square or the protractor, anything. In case of computer, you can use perpendicular line reference and do it. Now assume that I have maintained 90° and through B you have to draw a line, you have to maintain perpendicularity with 1, 2. So it is very interesting. See, this is not vertical. You have to maintain 90° with respect to the imaginary lines continued 1, 2 and 2B, or you can keep this way. So you can have set square and do like this. See, through B one line, through 1, 2, you have to keep that aligned with 1, 2 and then draw a line through B. Similarly, you can do this way. So manually, in computer it is easy, you can draw perpendicular. Now this is very important to note. This is how you draw the locus. See, I am drawing this with all the required lines. See, this is locus of D with respect to the edge 3, 4. This is locus of A with respect to edge 1, 2. Again, this is locus of B with respect to 1, 2. Again, same thing with respect to 3, 4. Locus of C is this. So, if I continue this line and this line, this is perpendicular, imaginary. So, it must be clearly noted. This is perpendicular. Again, I am very particular. So, I project it purposefully and then to show you what exactly this line. 4, 3 I continued and also this I projected and then given perpendicularity. So the path traced by all corners, top corners, are actually perpendicular to the base edges. Here 1, 2 is the base edge. These are the loci of B and A respectively. This is loci of D and C respectively. Now same procedure you have to follow. Rotate the 2B for example, or 1A. Anything you have to take both, okay, because they are different. Okay, now draw this, then project. Again, draw this and project. Okay, you do both, irrespective whether it is constant, same length or different length. You have to do that. So here, this is, I will take only A as a reference. A1 dash. This is A1. According to the projection concept. Otherwise, simply you say capital A. Again here, this is capital D. This is capital C. That is on the locus of C. This is very crystal clear. We have horizontal, vertical, horizontal. With respect to 1, 4 and 2, 3, no problem. But with respect to 1, 2 and 3, 4, you must be very careful. Here, after that, you take the pick up. Commonly, people do mistake. They take A as reference and rotate. No, it is 1. 1 as reference. This is 1A. 1A. 1 as center. Base corners as centers. Draw arcs like this. This is A on the locus of this. Again, from this point, this is 2D. Actual length. Same length to be transferred here. Draw arc and keep this. This is capital B. This is capital B. C. Again, see how to do it. Again, 3A center. This is the length. Draw arc. This is C. Similarly, this is the actual length. Then to this, transfer this or draw arc, get D. Now, all points we got on the respective loci, join them. That's all. So, we got the actual development. Reduce this only. Okay. 1 to AB. So this is one part. Similarly, just opposite to that, 4D and 3C. 4D and 3C. Join them. Okay. So this is the final one. Again, D to A and C to B. So already I have joined this. Now draw the base edges also. Okay. So this is how you get the development of inclined base tray, taking into consideration, the height of the tray remains same throughout. In this case also, you can vary the height. See, you can keep instead of 10, you can keep 20. Same procedure you do. Anyway, you are rotating in both directions. Definitely, you can do same procedure and do it. At the same time, these gaps also maintain same as per the problem. These gaps also may be changed as per the requirement. As per the given figure, you can do it. Even though this is 10, this is 20, you can do. We have maintained 10, 10 each say. Then you can change that also. Only thing is, in this type of things, you have to maintain both. In this case, I can do only one if this is constant. Here, even though it is constant, you have to do on varying height also. You have to do same procedure. Rotate and project. Rotate and project, get the points on the respective loci. Here, I repeat, the locus of moving ends are always perpendicular to the base edges. In this case, 1 to AB locus. This is 4, 3 and this is common, vertical, horizontal. So this is what the projection, development of trace in this chapter. So we can vary the height and also shapes and do it. Here neither trapezium nor and also the rectangle. So it will work out the same thing on the computer. Let me discuss the problems on a trace of different types. Here I am giving you some models, colored references. The model which is having the rectangle as the base and then the inclined surface. So this is again the simple tray which I have discussed. Now we have 10 mm height and then the base is 80 by 50. Okay, this is what it looks like. It is normally used to serve something in restaurants, and also in industries they use it to carry some components, especially the cylindrical components not to roll. So like that you have many applications, and also in industries of various types. Now we have the procedure as I explained. These are referred to as 1, 2, 3, 4 as well as ABCD, because ABCD the top corners are just above it. Okay, now I can give this reference. Just for the explanation purpose, I have made it little bit bigger so that you can understand better. Even this type of trays are available for a specific reason. Now let me name this as 1, 2, 3, 4 as the top view of the base of the tray, and ABCD as the top corners of the base. This is as per the projection concept. Now I have shown from all the corners ABCD. I am referring ABCD only, not 1, 2, 3, 4. ABCD in top view. Same as 1, 2, 3, 4. Drawn the vertical and horizontal line because the base edges are horizontal and vertical. So with respect to 1, 2, we have these vertical lines as the path. Again, with respect to 2, 3, we have horizontal lines for the path as BC. Similarly for D and A. Now, I have shown is locus of top corner CAB, etc. Now, what you have to do is, you take the same distance and 1, 2, 3 as centers, draw. Actually, it is ABCD as center, draw. That's what the reference is. Okay. Now, instead of that, you can rotate this and then get in one go. Now, I have made this arc, make it parallel and project, and the moving locus. Moving locus is B. It coincides with 2. Here moving locus is A, coincides with 1. So naturally you get this as B, this as A, and D and C. Next, this is about the left surface and right surface. What about the top and bottom? If you make it flat surface and then rotate and keep it on the flat surface. So here somewhere here you will get C and this is D. Definitely all sides are equal. You can take 2 B as center, draw arc. With respect to this, you will get one more B here. Like that A you get here, D and C. Now the same thing is carried out here. Otherwise, since it is same, you can draw horizontal lines from this also. It is as good as drawing the arcs here because of same distance. Now join them with lines. Now you will get this. For explanation purpose, I have made this coloring. The lateral surfaces are made it on the flat surface, rotated and kept on the flat surface, and then got this light blue color, and then yellow color is representing the base of the tree. So this is the answer. Now finally you have to have dark lines for the required lines, and procedure you can show with light lines. See, this is front view and this is top view of the arrangement, at the same time including development. So this is the final answer or solution for the given problem. Now if I take the lateral surfaces inclined like this, see, the lateral surface inclined, the base is 60 by 30 and the top edges are 50 by 80. But in case of this, the same distance, see, 50 by 80 is the base distance as well as the top. Now we have the thing is the distances are same. Here it is different. Now if I take up the problem, this is the wireframe model and this is the model which is colored. The outer look is this. Now the top and front views. If you look from front, you get the trapezium, and if you look from top, you will get two rectangles. Okay, with respect to same center, same orientation. Now how it is possible? They give like this. The figure they give. Okay, so you have to create the same figure with plus mark. You can create 15, 15 vertically, and then here 30 and 40. Then create two rectangles and join these corners with the top corners. This really represents slant edges of the tray. Okay. Now to get the development, what you have to do is you must keep these light lines. Purposefully I have made it dark because to explain the top and front views of the tray, I have done this job. Even here you see the dimensions are clear, 60, 80 and 30, 50, and this is 20. Now how to get the true length of all slant edges in one go? So here, as I told you, rotate and make it parallel, project on the, since it is 2, 3 is vertical, this is the locus of B with respect to 2, 3. You get one more B here, that is on the locus of B only, perpendicular to 1, 2. Since it is horizontal, you can draw vertical through B. Okay. So this is simple reference for you, how exactly you get the true length of this slant edge. Yes. And for all sides you get, see, path of top corner C or locus of top corner C. Similarly for B, this is for A, this is for D. That is as good as the first problem. Now here is the reference is to draw the locus is A. Okay. To take the total distance of the slant edge 1, 2, 3, 4 only, because 2B2 is the true length. And if you want 2B2 same length on this locus, 2A center, 2B2 equal to draw arc. Okay. Similarly, same thing, 4D2 as a radius, 4A center, draw arc. 1A2 draw arc. Again 3C2 draw arc. Now after this is only for reference. Actually you have to call this as capital B, this is C, this is D, this is A, capital A. This is because it is development. So I first complete this on the respective loci, identify the points, then say this is AA, BB, CC, DD in two directions mutually perpendicular to each other in this case, because the base edges are mutually perpendicular. Next, join the top corners A, B, C, D in the respective sides and get this. Again here I have made color because to get the clear idea. See, this is AA, you have made this AB, BC, CD and DA. Here you get 2 points AA, BD and CC for each corner, okay, with the same height, same distance. All slant edges are same. Okay. So this is how you can complete, and completed one should be placed in this way. Okay, with all dimensioning, minimum dimensions, whatever given you must keep, and then present it well. This is base and this is the corresponding lateral surfaces which is placed on the flat surface. And see, I have maintained the original top and front views, top view very light, so that you can see the dark lines for the development. Okay, So this is how you complete the problem of train with the same height. Suppose you have different height, here it is 10, 20 or vice versa. So how to do it? See, here is the reference. Here I have made 30 and this is 20. See, 30 and 20. You can make it 30, 15 also, no problem, as per the requirement. So how to do it? Same procedure. Only thing is, instead of keeping the, you are going to keep both sides arcs, but here you get different distances. That's all. See, I will show you how exactly this one happens. See, you rotate this same distance, different height, same procedure. Okay. Now you get AB2 works for this side, two length for this side, both from 2 and 3. But here it is different. From 1 and 4, the two lengths are different because it has got different height. So naturally you process with the same logic, project it, get 1A. 1A is the true length for 1 capital A in this, again 1 capital A. 4 capital D, it's already available here. Rotate this with 1 and 4 as centers, not with 4 and A and D as centers. Wrong. So you will be getting wrong answer if you do that. 1 and 4 as centers, draw arcs to the other sides. Here also the base edges are horizontal and vertical. Definitely you have the mutually perpendicular locus. This is loci of D in this direction with respect to 3, 4. With respect to 1, 2, this is locus of A. Similarly for B and C. Now this is very clear. 1, 4 and 2, 3 are vertical. Definitely you are going to have horizontal lines. Next, how to complete this? See, this is how you can complete 1A to 4D2, 3C2 and 3B2. Because you can observe here this is smaller and this is comparatively bigger because of this height 30 and 20. Next comes the top and bottom surfaces. How to do it? See, rotate here and rotate here. Left side take 2C2 or 2B2, rotate. And here right side, left side you have 4D2 and 1A2, rotate either side. Then you get the equal distances, then join them. Okay, you get the development, complete development of the tray. Retain the top and front view dark only, and top view make it light so that the development is going to dominate the final view because with dark lines 0.5. So this is the final solution for this. Now, let the base surface of the tray is trapezium instead of a rectangle. So how to do it? This is wireframe and this is the modeling type, and you have the problem like this. Problem you get like this: 80 either side, 10 mm, 10 mm. It can be varied. This can be 20. This is 10, or this is 20. This is 10, or same distance. No problem. As per the given dimensions, you have to draw the tray, top and front view. This is the top view of the tray, given 50, 70, 30 and 40. What you have to do is first you create 30, 50 and 80. With respect to this is symmetrical about this, you create a trapezium. Again, this symmetrical about this. Again, you maintain 10 mm each and then fix this 25, 25 and 70, 70. 25, 25 already you have done. 35, 35 you maintain here and 20, 20. Then whatever the points you get, you join with this. That's all. Now you get this. The front view, you get constant height throughout. Even here you may get different height, different distances. Okay. Now let me discuss this here. The procedure, as I told you earlier, I will try to enlarge. See, the locus of D perpendicular to the base 3, 4. Perpendicular to 3, 4. How it is possible? Okay, now how to draw this? You can use this perpendicular line, perpendicular to. Here this is there, perpendicular to, and then draw it. Okay, so we can easily do that by using this. Now, with all corners you draw perpendiculars. There is no issue with these lines. So horizontal lines through B. B and C, and again D and then A, because they are vertical. Since it is inclined, you have to draw perpendicular lines. Okay, so after doing this job, how to get the true length? See, rotate here and also here, because you have to do both sides because of the change in inclination, and the true length of 4D is different, and the true length of 3C is different, even though it is constant. Okay, now after this, get marked A2, D2, B2, C2 as usual with the previous case. Now how to get the points on this perpendicular locus of C perpendicular to 3, 4, locus of B perpendicular to 1, 2. Similarly, locus of A perpendicular to 1, 2, locus of D perpendicular to 4, 3. After marking this locus perpendicular to it, draw arcs. 3S center, C2 equal to radius, draw arc, not as CS center. It's very wrong thing. So don't go for C. C is dangerous point here. Again B. 3S center, 3C2 equal to radius, draw arc. I have seen people who have taken CS center, C2 C2 equal to draw arc. No. So it's not allowed. You never get the required tray. You will get something else. Now draw like this. See. Draw arcs. So this is capital D, this is capital C, capital A, capital B. Even you replace B2, C2, D2 and A2 as capital letters, so that you can get the development and join. See, that's what I have made. A, E, B, B, C, C, D, D. And see that they are particularly on perpendicular lines, not on vertical lines. So majority of the time I have seen people have kept on vertical and horizontal lines, even though it is inclined. So you must be very careful. Basic concept is this, you have to follow carefully. Now, this is the answer, final answer. So, suppose that you have what is called the different heights. Okay, so same thing, you get different height. So their constant height is different height. You are, irrespective of whether constant height or different height, you are doing both sides. For getting things, same procedure, no problem. Different heights. Follow this, then get it on the respective loci. Draw perpendicular to 4C, 4, 3 through C. Again draw perpendicular to 4, 3 through D. Similarly through A and B, perpendicular to 1, 2 to get A and B in this direction. Now finally you get the solution for inclined tray with the base incline. Suppose that you get, instead of 10 either side, you get 20. Same procedure, no change. Accordingly, this true length will change, that's all. So again, same procedure, identify the loci and then keep this final. So here they're all inclined, you get the solution finally. Okay, so final solution. This is how you can work out the problems on trays. You will get the top and front views, particularly for trays. The dimensions, you must post the dimensions as per the given values and see that it is different height or same height carefully, and then work out. So again, I repeat, I conclude, whenever you draw locus through the moving end or the outer corners, you must see that it is perpendicular. If it is rectangle type, two mutually perpendicular lines will work from each corner. If it is inclined like this, then you must be very careful. Draw perpendicular to the base edges. Okay, that's all. So now let us see any extra problems we can do in development for module 3 in coming sessions.